Hello everyone and welcome to today's workshop. So as you know, we will have the second day of this marine data for ocean health. So this is a Copernicus Marine Service workshop and today we will have the practical session. So as you know, 2 days ago, we gave you an introduction to the Copernicus Marine Service and what sort of data you can find. And we also provided some examples on how you can use the data for ocean health issues. And today we will have the practical session with the tutorials and we will show you how you can visualize the data sets and how you can apply it to a case study. So before we start, we are going to go through some house rules and guidelines to help you follow these workshops in the best possible way. So first, please do not use the chat that you see on your right-hand side for your questions. You can use it for small talk or say hello to us, discuss with each other. But if you have a more technical question or if you have any other question, we will use the Q&A section on the website. Wait, still a bit of delay. Okay, yeah. So we will use this Q&A section that you can see on the top bar of your page. We will also provide the link in the chat for you to use. And when you click on it, there is an area dedicated to the Q&A, and that's where you can ask our speakers your question today. You can also have a look at the polls, and you can answer anytime to it if you want. And concerning the agenda of today, we will have 4 demonstrations. So we will start with Anaïs that you saw 2 days ago with the Copernicus Marine Toolbox presentation, a very useful tool. And then we will have 3 tutorials. So the first one is a Jupyter Notebook made by Alexandre Omerin from Noveltis. Then we will have Daria Andrievskaya that will present to us the QGIS tutorial. And finally, Simon Millet will present us the RStudio tutorial that they developed for this workshop. And as you know, so it's practical session, you might have already take a look to the tutorial that they made for you. And yeah, if you have any kind of question, it's your time to shine in the Q&A section for them to answer to it. So we will start with the Copernicus Marine Toolbox presentation. So Anaïs, whenever you want, the floor is yours to start the demonstration.
Great. Okay. Up. So good morning, everyone. I'm Anaïs from Copernicus Marine User Support, and welcome to this presentation dedicated to the Copernicus Marine Toolbox, our data download tool. So Copernicus Marine Toolbox is free, user-friendly tool that interacts with Copernicus Marine Data Store to access complete metadata, full data sets, or specific subsets of digital models, satellite data, or in situ declaration. It lets you select and extract only data you need in optimized format and offer a wide range of simple and complex filters via direct connection to the Marine Data Store without any volumes and downstream limits. In short, the toolbox allows you to explore and download all the products variables in our catalog without any quota restriction. Among the many benefits is the ability to download data with significantly improved performance. This is due to the conversion of all dataset to analysis-ready cloud-optimized format, ARCO. Analysis-ready means that the data has been homogenized for ease of use and interoperability, whether from time series or geospatial queries. The cloud optimized indicates the state-of-the-art technologies are used to store data optimally and enable fast parallel access. The Copernicus Marine Toolbox offers this new access service via the GeoSeries service, provides a version of the data with a small chunk size for the time dimension and a large chunk size for longitude and latitude dimension. It's optimized for analyzing large geographic domains over a short period of time. The time series service provides a version of the data with a small chunk size for latitude and longitude dimension and a large chunk size for the time dimension. It's optimized for analysis complete time series over a relatively small area. And you have the original file service, which provides a version or an original version of the data as published by producers via direct connection to the marine data store. So I will show the main feature of the Copernicus Marine Toolbox and provide concrete examples to illustrate how quick and easy it's to download Copernicus Marine using this tool. Oh, sorry. So the toolbox provides 4 main functions: logging, which automatically generates an encrypted file containing your login credential, so you don't have to enter your credential every time you want to download the data. The describe functions retrieves the products and datasets metadata from the Marine data store. The get functions enables you to download the original files exactly as provided by producers. And subsets allows you to extract only the portion of the data you actually need, especially temporally or by depth. And this function can be both used on the command line interface, like a Mambas, Miniforge prompt, and a Python interface, like Jupyter Notebooks or Visual Studio Code. So now, to learn more about this tool, please visit first our help center here. So go to the Copernicus Marine Data Download Tool section, and then scroll down and click on Copernicus Marine Toolbox section here. You will find the Getting Started with the Toolbox section with introductory articles and details on the installation and usage. The main functionalities subsection here, you will find all the articles on each toolbox functions for command line and Python. The use case subsection addresses a number of specific download requirements and also how to use Python on other programs such as R. In the troubleshootings and FAQ section, you will find several articles, including 2 articles on the presentation of the latest versions, 2.00. Troubleshoots articles which list known issues and provide solutions. FAQ article with the question most frequently asked by our community. An article on data formats available with the toolbox, NetCDF and ZAR. Reporting an issue of feature request article, which tells you how to do it, raise a problem or a request for development. And the milestone and roadmap, which inform us about the past and the future improvement. And finally, there is an archive toolbox guides with the version 1.3.5, which all the articles on using this version. So we assume you have already installed the Copernicus Marine Toolbox on an isolated Python environment. So you have already consulted and followed the procedure in the installation articles. So we are now going to start exploring the toolbox via command prompt using Miniforge prompt. So the first things to do is to open the Miniforge prompt or the shelves of your choice. So next, you need to activate the environment in which you have installed the toolbox. Mamba activate CMT, where CMT is the name I've given to the environment that owns the toolbox. So as you can see, I'm no longer in my base environment, but in my CMT. So to check which version is currently used, simply run Copernicus Marine -- version. And now I see I'm using the latest version, the 2.00. So let's take a look at the ones of the toolbox only functions that doesn't require logging details, the describe function. This function allows you to obtain the metadata of a product in our catalog. So to obtain the options of variables, first call up Copernicus Marine and specify the function, describe, and add the help option to obtain an overview of all options available. So here on the left, you have all the options that can be integrated into your query, and on the right, their description. I won't go into further detail on this function, but I invite you to consult the related article in our help center. So before proceeding with the data download function, we recommend that you use the logging function once so that you don't have to enter your logging details every time you download. So this function will create a locally encrypted identification file which will be automatically used on your request. So I simply write Copernicus Marine logging. So the toolbox will ask for my username and my password. So be careful because the writing of the password is hidden. So as I already created my identification file, it's asking me if I want to override it. I say yes. And when I go to the .Copernicus Marine folder in my home directory, I find this created file. So the first toolbox functions I'm going to show you is the get function, which lets you to retrieve the original files as supplied by producers. So many functions are available. So to check them, run Copernicus Marine get help. No, sorry. Copernicus Marine get. So here you have all the options of variables, and the only mandatory parameters is the dataset ID here. So I type Copernicus Marine get I. If I run the command with just the dataset name, the toolbox will download all the data contained in that dataset. This will require a lot of space, free space on my machine, and it will take very long time. So let's take, we want to download some specific data. And the first thing is to check the availability of the data I want in the catalog. So I go to the Copernicus Marine data store here. And let's say I want the data on this product. Then in the data access tab, I found the dataset I'm interested in, and I click on the browse button to look at the native files available. Okay, and for example, let's take the data from January 6th. So in my command, I enter the dataset name, and add the filter option to specify the desired date, 2025-1/6, for example. And we can also specify where to save the files using output directory or just O for short. Documents, data. Okay, so not that message appear here are information message about the dataset version used, the part of the dataset in which we are looking for data, and a message telling you that the file search is in progress. Since the version 2.00 download starts automatically, if you wish to open details metadata of the data collab, you need to add the dry run option here to get to the get or the subset command, and no download will be performed. So the downloading makes some time. So I need to wait. All right. So the downloading is finished and I will receive the message. Yeah, here. So the downloading is complete and I found in the folder in indicated directory with the name of the product, the name of the data set, the year, the month, and the data file. So now let's take a look at using the toolbox on Python interface. So first, open your preferred Python environment, like Visual Studio Code for me. And the first things to do is to switch to my CMT kernel here, or your Python or your toolbox environment. And then you must first import Copernicus Marine Toolbox, Copernicus Marine package. All right, so let's move on the subset function for extracting specific data on Python to see the option of a function similar to the help argument. You can do Copernicus Marine dot the name of the function subset and add a question mark. So the subset function is essential if you want to get only part of the data set, and you can use the available help option to build your query or generate it automatically using the automate button on the online subset page or from the MyOcean viewer to avoid errors. So let's go back to the product dataset page here. I click then on the form button in the subset column to access to the online subset page. And I'm going to select the data I want to extract, for example, this. So now I click on automate button and I click on the Python API for copy this template and paste it in my notebook. All right. We can add more options like output directory to define where I want to save the data. And the output file name to name my data, for example, subset C. All right. So now the download ongoing. All right. And if I return in my folder, so now the data is created here. And this is my data file. So now let's take a look at some options that can only be used on the Python interface. Open dataset and read data frame functions. So these functions allows you to open data remotely rather than downloading it immediately. So let's start with open, see the open dataset options. So you will notice that the available options are very similar to those of the subset. If you specify only the dataset name here, it's attempts to open all the data remotely, but here I want to remotely open this previous command. So I just replace here subset by open dataset. And I will remove options that don't apply to it. And I also insert my command in a variable name dataset, for example. All right, this is what my data looks like in a X-array. If I want to save it locally, I use the function to_netcdf. So dataset to netcdf, in which I specify the path where I want to my files saved to be saved. Data subset to point and see. Sorry. So here I will find my data file in the directory indicated. So the last function is the read data frame functions. So these functions behave like open dataset, but it's return your data as a pandas data frame, which can be saved in CSV format with the two CSV functions. So because data frame can be quite large in memory, it's best to create a manageable subset first. So here, read data frame, subset 2. So I will replace also open data set, and we will see if the volume of this subset allows opening in the data frame. All right. So my data can therefore can open as a data frame. You can then do data set to point to CSV to save your data frame as a CSV. So this data can it can take longer to extract in CSV, but it will be easier to make sure that the region of the period requested are not too large. So in my folder here, I can find the data in CSV format. So we have now explored all the measures options of the Copernicus Marine Toolbox. Not that not every data set in our catalog is currently available in a subset via the subset service. So please check in the user notification service details on which data set support subset function. So now go to the incident here, and you will find in this notification dataset in progress for being formatted in the service subset. All the datasets that not apply to a subset. So if you have any question or issues that aren't resolved by our Help Center or by Blue, our EA assistant, you can also contact our support team directly. So thanks you all for your attention.
Thanks a lot, Anaïs, for your presentation. So we will move on to the Q&A section. We have one question for now. So this question asking if the script will be shared. So I mentioned the replays will be made available today, but I guess all of the functions you present are explained in articles, if I'm not mistaken.
Yeah, that's it.
Yeah.
It's a very basic command, and all articles are much details on each functions.
Okay, thanks a lot. So for now, that was the only question on the Copernicus Marine Toolbox. So I think it was quite clear. We can wait a few seconds, but for now, it's only with Python language, if I'm not mistaken, also.
You can use it on Python and also in R or MATLAB, and we have some articles on this program in our center. But for some functions like open dataset or read data frame, now it's only available in Python and not already for R. But our developers work on it.
Okay, thanks. Okay, so I see this question. Okay, no, we have another question that just came. If we can go back to the Q&A section, please. Could you show the second place you are using? It's the Dame Dark Screen. I think it was.
It was the Visual Studio Code.
Yeah.
But you can also use a Jupyter Notebook or the Python interface of your choice.
Thanks. This question, so for a specific geographic point, can we know what models and data are available?
So first of all, I recommend that using the MyOcean first for explore all the product and data variables. And you just have to first select your geographic point, for example, and you also have all the products that can product data for this location. And if you want many details about these models, you have to check in the user manual or quality information document to have more information about this product.
Thanks. And yeah, for the MyOcean viewer, the replay of 2 days ago is available. So if you want to have a look at Annie's demonstration of MyOcean, you can too. Next question. What is the required computer processor to run the programming language?
You have in our installation articles links on the pre-require computer processor, but globally it can be used on all computers.
Okay, good to know.
Very light program.
This question, so do I have to create a new Python environment?
Not in this presentation. I don't have a, I already installed the toolbox in environments before this presentation, but we invite you to consult the installations articles. And if you have a problem, you can ask to the user support, and we are there to help you if you encounter difficulties.
Thanks a lot. So a more general question, does this platform also help track or prove the movement of illegal fishing? So I don't think there is data on fish, if I'm correct.
No, we don't have data in fish.
Yeah, so it would be external data for this type of issue. Can we check the data quality, for example, like cloud cover or something?
You also have in the Copernicus Marine website a quality dashboard. When you have selected your product, you can check this quality or refer to the this documentation, the documentation like the great information document, for example. And for like the cloud cover, I don't think that the Copernicus Marine have this data, but perhaps the Copernicus Land or other service of Copernicus.
Yeah, maybe we will have to check, I think. Okay, thanks a lot. This question, do you use other programming language as well except Python? You're mostly on Python, if I'm not mistaken.
Yeah, the Python, first Python, and then how developers work on this application in other programs like R or MATLAB, but it's still in progress.
Can we subset region using the toolbox?
Yeah, sure.
Yes.
Using the subset function, you can use the automate button to automatically generate your template, but you can also use these options of the function to create your own request.
Thanks a lot. Always good to know. Why do we must use CMEMS kernel? Is it just a matter of machine power?
You use the kernel, you choose the kernel in which corresponding to your CMT environment. My environment is CMT environment, so I create the kernel. It's explained in our articles in the Lab Center. So I tells Visual Studio Calls to connect to this specific environment. So we have to connect to the right kernel for use the toolbox.
Okay, thanks a lot. Another question. So what kind of data storage technique does it use in the background? Is it capable of querying data, spatial and in time, at the same time? I'm not sure to understand the end of the question.
No. I don't understand well this question. So, okay. In the GeoSeries service is used automatically. The toolbox shows automatically which service, the GeoSeries service for large geospatial queries, or the time series service for data with a large time series, but the toolbox shows in automatically. You can also specify it in the thanks to the options of the function.
Okay, thanks. So I hope this answered the question. And one last question, more general question about the catalog. Do we have any projects or products on shallow water bathymetry using Copernicus data like Sentinel-2, especially in Central Indian Ocean region? So
I don't know if Copernicus Marine have any project on this subject. Perhaps if you're looking in the use case service, you can find some project of Copernicus Marine. But now I don't know if we already have this kind of project.
yeah, I was thinking maybe the use case or the tutorials, but
Yeah.
I'm not sure. So it should be, you should take a look at on the website to see if you can find something related to that. But there is definitely products in the Central Indian Ocean. So. Okay. So thanks again, Anaïs. We will have to stop there with the question. For the question left, it will be on the post-event report, so no worries about that. Thanks again for your presentation and your participation.
Thank you. Bye.
And yeah, Alexandre, whenever you want, you can come and do the Jupyter Notebook presentation. Welcome.
Yes, thank you, Gaël. Hello, everyone. So I'm Alexandre Brun from Noveltis, and so in this session I will present to you a Jupyter Notebook written with Python. So I just started sharing my screen. I hope that everyone can see it. Is it visible?
Yes, it's okay. Thanks.
Perfect. So yes, for this notebook, the topic will be so the monitoring of a few ocean variables in the Mediterranean Sea, with a focus on variables affecting coral reefs. As an introduction, like corals are well, a very specific ecosystem. It hosts a big proportion of the marine wildlife and very diverse species. But so those ecosystems are critical in the ocean, but they are also very vulnerable, especially nowadays because of global warming. And there are several drivers that affect corals and increase the chance of mortality, such as ocean acidification, the rise of temperatures, pollutions, and the increase in frequency of other extreme events like hurricanes or typhoons. And so in this training, we will look at two of the main drivers of coral mortality, which are acidification and seawater temperatures. And we'll focus on the Mediterranean Sea, which, for example, has red corals like this one in this picture. So as I've said, we will use Python for this tutorial. So if you are already familiar with Python, there are probably some libraries that we're going to use that you already know. NumPy is great for computing data arrays. Pandas great for working with tables. And Xarray, you have a glimpse of this library in the previous presentation, which is used to open the NetCDF data in which are stored the scientific data like temperatures and everything that is provided by the Copernicus Marine Service. We also use SciPy to compute a few statistical calculations. Matplotlib and Cartopy are used to draw plots and maps, and datetimes is used to process the time series and dates that are used to in the structure of the datasets. So I'm importing all of these libraries using this cell. Don't forget when you open the notebook to use the Copernicus kernel version 4. Because this is the one that has the Copernicus Marine Toolbox installed. So here's a brief presentation of the main datasets that we are going to use in this training. So in order to look at acidification, we will look, of course, first at the pH of the water and also at the carbon dioxide surface partial pressure on the water, because acidification is driven by the absorption of carbon dioxide from the atmosphere to the ocean. So to monitor this, we will look at the Mediterranean Sea biogeochemistry reanalysis. So this dataset is provided by the Copernicus Marine Service and is available on this page. You can visit it to have more information, to investigate which models are used to compute this data, which observations are assimilated to enrich the dataset. And there is a user manual and quality information document if you want to explore even more about this data. But the main takeaway is that this data covers a wide temporal has a wide temporal coverage from 1999 to 2024. So we have almost 25 years of data. It comes in daily, monthly, or yearly resolution, and has about a 4 kilometer resolution, a little more. So in our case, we will use monthly data because we will try to look at general trends in the long term. So monthly data is enough. and it will allow us to maintain a manageable file sizes. So the Copernicus Marine Toolbox has already been presented in the previous presentation. So here just a quick overview. So as I've mentioned, use the version 4 because it is the one with the Copernicus Marine library pre-installed. And here is the subset function that was presented to you before, but this time adapted to our dataset here, Mediterranean geochemistry analysis. So I've retrieved the product ID from the data access menu, which I have copied here. And then I have selected here the pH variable. Just after that, I will download the CO2 variable because it is stored for another ID. Here I'm subsetting over a specific region, which I have defined here. You will see later where it is located. Here is the temporal coverage that I want to retrieve. Here is the depth coverage that I want to retrieve. And here is the output parameters that I want to define. And basically, my data will be stored here. So it's one of those files. Yes. Okay, so to save time, I will, as I have already pre-downloaded everything, but if you use a notebook at home, you will have this output when the data is downloaded. And if I open it, so here is my pH dataset. And you can see that I have a 4-dimensional dataset, so with latitudes and longitudes and time, but also depth. We have 9 levels of depth, which go here, you can see from about approximately 1 meter to 22 meters depth. And here is the pH. So you can explore the metadata clicking on this icon. And here you can have samples of the values. So here it just shows you the number of values because there are a lot of them. But for time, for example, you can see that we have indeed monthly data, 1 sample per month. So first of all, what I want to do is to simplify this data set. So we don't need to work with something that has several depth level. So in order to suppress this dimension to have an easier data set to work with, I'm computing the average over the depth dimension. So using the min function, sorry, I'm just going to display it to you. So you can see here that I have averaged the pH over the depth dimension, and now the depth dimension has disappeared, and it will be easier for us to work with the dataset. So you can see that we have only 5 latitudes and longitudes values. So because we are working on a very restricted area. So we'll show it to you in the following plot. So we are here. We are right under between Corsica and Sardinia, and we have downloaded data in this little square here. And this is indeed a sample of our dataset. So here it's from pH from August 2020. So you can see that visualized like this, we have only a few pixels, but in a broader area, you can understand where it is located. So now we're going to examine the correlation between CO2 partial pressure and seawater acidification. So as I've said, acidification is driven by the absorption of CO2. So this is what we're going to verify in this section. So in this section, I download the surface partial pressure of CO2, so from the atmosphere to the surface of the ocean. So here are the same parameters, same area of interest, same temporal coverage. And if I open it, here's my dataset. This time we don't have a depth dimension because this is data only on the surface of the water. And this is our scientific variable. So now what I want to do is to compute the time series for the pH and the carbon dioxide. So basically, I'm going to average the two variables on the longitude and latitude axes. So only the time dimension will be remaining. So this is what I'm doing here. I'm using again the mean function using latitude and longitudes. And to compute the correlation, we will perform a linear regression using the SciPy library. So in that way, we have a correlation and also the general trend using the same function. So here we have the results of the linear regression from SciPy. We can see that we have a correlation coefficient that is very close to -1, which indicates a strong correlation between the two variables. But this is not very eloquent, so we're going to visualize the two time series, plot one versus another to verify that they are indeed quite well correlated. So this is what we're doing on this plot here. So those are the two time series, so one for pH, one for carbon dioxide partial pressure. So you can see, of course, the seasonality of the two variables. And on the right panel, you can see that the different data points here almost form a line with a little bit of a curve here, but are still very close to the general linear trend that we have computed in the previous cell. So this shows that the two variables are highly correlated to one another, which of course, is consistent with the fact that acidification is driven by CO2 partial pressure. You can see here that the different peaks here are always corresponding, for instance. Okay, so in the next section, I'm going to show you a monitoring of the seawater temperature and try to link it to episodes of mass mortality in corals that have been recorded in this region. So here for this section, we have retrieved external data, so not from the Copernicus Marine Service. So the dataset is cited here. You can visit the dedicated page if you want. If it loads, apparently it's not loading, so I'm just going to keep doing the training. So we retrieve an Excel file from this publication. Okay, apparently the link is not active anymore. And so it consists of a recording of several mass mortality events that have happened in the Mediterranean Sea. So you can see a sample of the dataset here. So we have the name of the location, the coordinates, the dates for which it was recorded, etc. And so you can see here we're using pandas to open this, but we have a lot of parameters here that are not visible because there are a lot of them. Here we can see that there are 33. We can print all of them using the columns attribute on the dataset. So you can see that there are a lot more details here about the species group and drivers for each coral ecosystem. And I've also printed here the total temporal coverage of this dataset that we have retrieved, and we can see that we have episodes recorded from 1979 to 2017. And now, if we have a look at the dataset, let's look at the different locations of mass mortality events, and we will see if there is one located near Corsica because it was our area of study. And here you can see that we have a few episodes here. and one here that seems to be between Corsica and Sardinia, which was the area that we had been studying, that we have been studying until now. So if we zoom in a little more, only on Corsica, you can see that indeed we have data here, which is where we were focusing on our analysis. And now we can add the years of record of the mortality episodes to know when those recording date from. And you can see that all of them are from 2003, which is a year that has been that is famous in this region in Western Europe because it was a very high heat wave episode. Was one of the most severe actually in the last 25 years. And so now that we know that we have had mass mortality events, let's see if and that it's consistent with a known marine heat wave episode. Let's look at sea surface at sea water temperature to see if it is if the data is consistent with these recorded episodes. So once again here I'm retrieving seawater temperature data from the Copernicus Marine Service. So here is the ID of the dataset. And here we have a little higher temporal coverage for this dataset. Same thing here, we are retrieving the data, opening it. So we'll still have depth levels for this data. So as we're looking for temperatures that affect corals, we will not be looking at surface temperature, but rather at a temperature at around 20 meters deep. So here we have a few depth levels temperature. But if we had more and we couldn't really see which exactly depth level were available, we could use the cell function of X-array, specify a depth level of 20 meters, and choose the nearest depth level available in the data. So here, for instance, we can see that it will be 19.4 meters. And finally, we're also computing the time series, so the mean along latitude and longitude. So if, oh sorry, I've forgotten to compute this cell. Okay. So here is a general look at the time series. You can see the seasonality in the data and a few spikes here and there that are quite high compared to other years. And now we're going to compute marine heat wave days in the region using this time series. So we will compute two indicators, one of which it will be a little complex operation. So we have 30 years of data, and for each day of the year, for example, 1st of August, 20th of October, etc., for each of those days, we will compute the 90th percentile of the temperatures. And so that way, for each day of the year, we will have a threshold for exceptionally high temperature. So we compute this indicator for each of the day and count them and count the marine heat wave days for each year. But so defined as such, we will have marine heat wave days that will include winter days, for example. So even though those days are exceptionally high relative to the season, they will not be at temperatures that could be lethal to corals. So as a second indicator, we will also compute a threshold, a simple threshold at 23.5 degrees. So this is not necessarily a lethal threshold for corals, but it's already a temperature that, if exposed for a long time, can damage coral and, for example, increase coral bleaching or favor the propagation of disease, for example. So this is a threshold that we have chosen for this analysis. So in this cell, we compute the two indicators. And in this final figure, we plot the two indicators, so for each year. which results in this graph. So for each year, we have in gray the number of computed marine heatwave days, and in red the number of days above this sublethal threshold of 23.5 degrees. And you can see that in 2003, this year had an exceptional amount relative to the previous and next year's amount of extremely hot days. And you can also see that in the most recent years, this frequency is increasing. So this shows that Mediterranean corals in this area will probably be more vulnerable in the future. So we're reaching the end of this presentation. Here are the few exercises that you can do if you do this training at home. So you can try studying other areas, examining other mortality episodes that are available in the dataset that we have shown you. So feel free to do this on your own after this session. And we're reaching the end of this training. So thank you very much for your attention, and I hope you enjoyed.
Thank you very much, Alexandre, for your nice presentation of your tutorial. So we have a few questions for you. So we can go to the Q&A section. So just for the first question, it was a late question for the previous presentation about the Copernicus Toolbox. So I will quickly answer it. So will the Copernicus Marine Toolbox work in a Conda environment, or you definitely recommend to use Numba? So Anaïs told me that it also works with Conda, but we recommend to use Numba to avoid version compatibility between issues between different packages. So you can use it, but be aware that you might encounter some issue with different version. So for the question of the tutorial, the first one is, can I use VS Code instead of Jupyter to run the codes? What are the difference between the two? And are there some action I can do better in one than the other?
I don't think that there is any difference regarding what you can do regarding code execution or possibilities. What matters is that you have the same similar kernel installed, which can run the libraries that I have used in the notebook. But whether you use Jupyter or Visual Studio Code doesn't really change anything regarding the actions that you can do.
Okay, thanks a lot for the explanation. This question, is it possible to connect MATLAB data to Jupyter Notebook? If I have image processing data in MATLAB, can I visualize it within Jupyter? If so, how can I do?
I'm a little less familiar with MATLAB, so that's a bit hard for me to answer. But I think you probably have to, I don't know, for probably export it and import it into Jupyter, but I don't think that the link between the two is very trivial.
I can put it on the side. Maybe
Yes,
someone
maybe
can
there are
have...
some procedures to import MATLAB code and execute it within a Jupyter notebook, but I'm not aware
Yeah.
of such a possibility.
Yeah, I will put the question on the side. Maybe someone knows the answer to that. Okay, so we have several general questions also. This question about what you show in the tutorial, and if it would be possible to show pH contours on the study area. I guess if you had some extra command line, you can do something like that.
Yes, probably. I haven't known it, as it was a very small area. I didn't really focus on showing it on the map. That's true. I think it was the aim of the question. I'm not sure.
Yeah, I guess maybe if it... I don't think it was for you to do a demonstration, just to know if it was possible to do something like that.
Oh, okay.
Yeah.
Ah, yes, I think it would then. Yeah.
Okay. I have plenty of questions. So this one, why don't you use different colored point for the pH and the PCO2 correlation? Or graphical design question.
Yeah. Well, for what I wanted to show, that just the for plotting the data points. So with CO2 on the y-axis and pH on the x-axis. I didn't think it was necessary to color the points. What mattered is that I could show the points and that they were close to the central line of the plot. So this was the main takeaway from the graph. So that's why I didn't think it was necessary to color them.
And if
in a complex
people
way.
want to change the color of the point, they can do that easily with the
Oh,
tutorial
yes.
also.
Of course.
This question about, so the last part of the tutorial, why did you choose the days when the temperature was above 23 degrees? Is it because this temperature is dangerous for Mediterranean corals?
So I've mentioned that 23.5 is not necessarily lethal to corals, but it is still a threshold from which, depending on the species, for a long exposure, it can damage further bleaching or the propagation of diseases. But of course, there is a part of arbitrary in the choosing of this threshold, but we are quite close to it.
Thanks a lot. This question, I think I saw almost the same 2 days ago. I don't know if you know the answer, but can we use Google Colab instead of Jupyter to work for that?
I don't know. I know that you can execute notebooks with this, but I'm not sure about the compatibility with the CMEMS environment.
No, I don't think it works with the CMEMS environment. Maybe, yeah, as you said, directly on the computer, but not on CMEMS. Okay. So, plenty of questions coming. So, I don't know. So, this one saying that you are using Python. Python is also used for AI. How do we use AI to get desired result? I don't know if you did you already use machine learning and something like that to do codes like this one?
I've used yes for some applications, but I mean here it's for monitoring, so I don't think AI is relevant in that case. But perhaps it would be for maybe forecasts.
Yeah, maybe. Yeah, I think it's more logical, obviously. Thanks.
Yeah, in this notebook, it's mainly about observation, so AI is not used here. But for example, I've used it to try to determine the bathymetry in areas where there is no data. So for this, AI could be useful, but this is not the. I mean, in our case, this is not the scope of the
Yeah.
of the training of the notebook.
Yeah, plenty of questions. I don't know what to look at. So this one saying, in the start of the presentation, you mentioned that this is for intermediate level. So is there any advanced level and which kind of practice can we make? I think the last exercise you propose at the end of the tutorials could be a way to practice a little bit extra.
Yes, probably. Yes, it will. Sorry, it's a good exercise to try to retrieve new data sets and perform similar analysis on the totally different data and adapt to another region. So it's already quite something to perform this in the Copernicus Marine Service environment. Yeah.
Thanks for that. So we have time for one more question and then we will have to move on. In my Jupyter lab, CMEMS v4 kernel is not present. How can I incorporate this kernel? So for this one, it's maybe an issue directly on the Jupyter lab. So I will have a look with the team in charge of the lab and we'll get back to you with this, but it should be corrected quite easily. So I will let you know. Well, thanks again, Alexandre, for your presentation and the question. I will stop there. For all of the unanswered questions, it will be put in the post-event report, so no worries. Thanks again, and we will have a short break of 10 minutes and we will come back for the two next tutorials, so the QGIS and the RStudio presentation. See you in 10. Welcome back, everyone. I hope you had time to enjoy the little break. So now, as you know, we will go to the QGIS presentation. And so, Daria, whenever you want, you can start the tutorial. Welcome.
Okay, so hello everyone. My name is Daria and I work at Novelties. And I'm gonna show my screen. Gonna take. I hope you can see it. Can you see it?
Yeah, it's okay.
Yeah, great. So today I'm here to show you how we can use various Copernicus Marine service products in QGIS. And specifically, we're gonna focus on an exercise about evaluating the impact of hurricanes on ocean ecosystems. So for our study case, we're gonna look at Hurricane Michael, which happened in October 10, 2018. And at this date, it had landfall in Florida. And this was a storm of category 5, which means it's a big storm. And the last storm that actually hit United States of the same category was in 1992. It was Hurricane Andrew. And Hurricane Michael, it reached wind speeds up to 260 kilometers per hour. And the waves during this hurricane also reached up to 7 meters high. Of course, it caused it caused quite a lot of devastation on the land, economical devastation, and fatalities, around 74 fatalities, if I'm not mistaken. So this hurricane, Michael, as others, they actually can have a big impact on ocean health, ocean ecosystems health. And mainly because when hurricane happens, when it passes over the surface of ocean, it causes mixing of water in ocean. So more nutrient-rich and cooler waters from the depth of the ocean, they go up to the surface, and as a result, we can have a water temperature that drops, and also as the nutrient-rich waters, they go up, so they mix. So of course, it's more nutrients, phytoplankton kind of benefits from it and starts to multiply more. And in the short term, it can be beneficial for ocean ecosystems or habitat, because more phytoplankton means more food, because this is a base of a food chain. So yeah, more food, the more production. So of course it can benefit marine habitats. But in long term, if duration of such event is prolonged, of course it can actually provoke harmful algae bloom. It also can deplete ocean from oxygen, and well, less oxygen is also means less happy marine animals, and well, habitat is not very healthy anymore. So it is very important to study such events as hurricanes, not only for the impact on land, but also the impact on ocean. So that's what we're gonna do today, and I'm gonna briefly show you which data from Copernicus Marine Service we're gonna use. You already know how to download it, so I'm not gonna talk about that. And we're gonna use 3 products. It's global ocean waves reanalysis, so to have significant wave height. Also, we're gonna use global ocean hourly reprocessed sea surface wind and stress for winds, of course, to see direction and wind speeds during the hurricane. And the last one is global ocean physics reanalysis, in which we are interested in seawater potential temperature. So we go now to our QGIS file. So here I'm gonna basically, I'm not gonna execute all step-by-step procedure, because it's gonna take much more time than we actually have. There's going to be videos, going to be PDF files, which you can use if you want really like step-by-step procedure. So here I'm going to use prepared project in QGIS. So first, to see the hurricane itself, its impact on the ocean and on the habitat. First, we're gonna see the significant wave height, and for this we use this variable. I'm gonna show you real quick. So you're gonna see that for this tutorial we used the NetCDF to GIS plugin, which was also developed in Novelties here. It's just a plugin that allows you to easily just easily import NetCDF files, and in the Copernicus Marine Source platform where a lot of data mostly presented in NetCDF files. So for the first part of this tutorial, we used, which one is this one? Yes. So the wave analysis with this data, with this variable, which we can add layers and stuff. I'm not gonna specifically do that. And here, we already have time frames from 7th of October at 3 p.m. till 10th of October at 9 p.m. The data is each 3 hours though. So we can see, we know that the storm, it made a landfall on Florida, on the Florida coast at afternoon of 10th October. So we're gonna see, we're gonna look at the dates also before, just to see how it emerged and how it proceeded. So we're gonna zoom a bit here, and now as we can untick the layers to see the progression. And for now, we don't really see anything happening with the sea. And then slowly, by moving through our layers, we actually see that here in this zone, we see that the waves start to go up. So yeah, for the color bar, we see that the blues means almost, well, we see calm sea, and the more red it becomes, the more higher the waves are. So here we can see how slowly the waves are spreading. You can see the wake of a storm. You see how it heats. You see how here we have a bigger and bigger, higher and higher waves. And we are approaching 10th of October. And on 10th of October, you see that here we have a very, very high values of significant wave height, and it approaches the coast. And on the afternoon, here it makes a landfall. You can see that it slowly dissipates, and basically at night of at 9 p.m. 10th, it's already basically passed. Well, passed in the ocean, on the ocean part, because you don't see the land, because of course it's on the land, but it slowly also dissipates. So like this, basically we could see how the Hurricane Michael is actually moving inland. And one tool that can be useful in the QGIS is to see, to plot this path of Hurricane Michael moving. For this, we can create a new layer. Like here, we can create layer, new shapefile layer, because it's a polygon layer. And then we can edit it by adding points. So basically this layer you can see now, which is called Michael Path, is layer that been made by putting points on each position of putting points at the position of the highest wave height at specific date. So for example, what was it, 7 of 10, for example, I think it's kind of somewhere here. Yeah, for example, it was here. Then on 8th of October, it moved, well, it doesn't say the date, but of hour, but yeah, when it moved. And then at the end of, when it makes a landfall, kind of, oops. Yeah, we see it here. So like this, we can actually track it and adjust attributes and add new attributes, for example, like date. For this, to add different attributes, we can go to attribute table. And for example, here we have a date column, which we can add new ones, like here, and put different expressions here. For example, in this one, let me see if it shows. No, it doesn't show. So yeah, specific formulas to calculate different values you want to have in your attribute table. So now, as we've seen how the hurricane moves, let's say, above water, and how it impacts the waves, we can also want also to see the wind, and for this we use another product that was wind reanalysis, I think also. So it has two directions of wind, and we can plot them by adding them to the project. They are added here. You can even see them. They look like this, but they don't really show some important information. So in this plugin, they actually have a very useful function. Is when we choose the both layers and we right click, we have vectorize function, which allows us to use these two dimensions, two directions of a wind to actually make a vector field out of it with direction of the wind and the speed of wind. And we chose only one date, for example, it was 10, yeah, to just see at its max how it's spreading. And I will show you, and that's how it looks like. Let me just, it's at 3 o'clock, okay, like this. So here we see the superposition of our significant wave height layer. We see that, for example, if I do this, we see how we see high values of waves here, and the superposition of our wind. And we see exactly that here, that's the eye of a hurricane. You see how it moves, how it swirls. And also you see that the values, let me show you the, yeah, the darker the arrows are, the higher the speed of the wind. So here you see, sorry, here you see that it's reaching very, very high values. So like this, you can have different vector fields, which is very nice. It also can be applied to not only wind, but also to current, for example. Next thing was to see temperature, as I said, because hurricane actually mixes the water, different layers of water. We can see a decrease in sea surface temperature. So for that, we can look at the seawater surface temperature from another product. And here we decided to look at 1st of October, so way before the hurricane, then on 10th of October, when it had a landfall, and 13th of October just before, sorry, after. So here we can see, yeah, the max is 31 degrees and 26 is a min. And this is our 1st of October, so quite warm water. Then during the during the hurricane, we see that the ocean gets colder. Like especially here, we know that at 10th of October, the hurricane was approximately here. We see that also water gets mixed and getting colder. And after we see that after the hurricane, we see that it's getting even colder. It's also important to notice that it also can be tied to the fact that, well, it's October, so of course it's slowly getting colder, so that also can influence the temperature of the ocean, of course. And also an interesting point to see is how just during the day when the landfall happened here, and after, we can see here an increased, well, a big drop of the temperature, actually, seawater temperature. And we know that here we have many rivers in the United States, so it also can be, potentially, it can be an influence of increased water discharge from the rivers due to rainfall, because of course when it's storming, when storm comes, it's raining, so it also could increase the colder water from the land. So as we have this, we also decided to quickly look how can it impact some marine habitats. And for this, we have this little polygon. And this polygon means essential fish habitats. So it's basically the most important habitats for fish, for different types of fish that are present in this region. So these are the main areas in which they which they live, they multiply and stuff like that, with reefs, coral reefs, and other features. So we decided to look how temperature there changes to see if seawater temperature changes. Of course, it can influence fish habitat. They can start to migrate from or to, depends, this area. And for this polygon is provided by, let me just see very quickly. Yes, it's provided by this site, by NOAA. And yeah, you can use it too. So what we did next with this is first we fixed the geometries with basically a function here, which basically allows us to fix geometries if there's some incompatibilities which we don't actually see with our eyes. And then we cropped our layers. So we have this temperature layer here, and we cropped each of this raster layer here according to this polygon to have those. Let me show you like this. For example, here we have one that corresponding to 1st of October, so before the hurricane. Here we can see that it's quite warm, right? And then we did the same for 10th of October. Here we know that the hurricane is here. And also for the after. And our goal for that was to see in the future to have statistics on that specific region of minimum, maximum, and mean values of seawater temperature in these regions. So for this, we have calculated this. It's 13. Let me just do it very quickly. So there's a such function as calculate statistics. Zonal statistics, yes. So this tool in QGIS is very, very nice because it allows you to check different statistics, like to calculate different statistics based on a raster layer, like here, for example, you can choose. And here it was temperature that was chosen. And as an input layer, it's usually a polygon layer, which allows us to, basically we have a raster layer and we have overlaying polygons, and it allows us to calculate statistics in this exact area, in these polygons from the layers, and we can have different statistics. You can see many, and we only were interested in mean, minimum, and maximum. And as a result, each time when you produce a new layer, it's going to be new polygon layer, which looks exactly as the same polygon we had before. But the most important is what's in its attribute table. Let me show you. I opened them all. Yep, like that. No, not this one. Yes. So we have all of our free dates. So this one is before the hurricane, this is during, and this is after. So we are interested mostly in these values, as I said. We can see that before hurricane, they had a mean value of 29 degrees. Also, we have a minimum and maximum. You see that not big correlation between them, which means also that it's quite stable in terms of temperature. Then during the hurricane, we see that each value dropped, and after, we also see even lower values than during the hurricane, and we actually see a bigger difference between mean and max. But as I said, also, of course, there are many other circumstances that can actually additionally impact the change in sea surface temperature. So that was it. It was a bit fast, I think, but yeah, I don't have more time to explain each step, but yeah, you will have video and PDF file in which you can see it more in details. So I hope you enjoyed it, and if you have questions, I'm here.
Thanks a lot, Daria, for your nice presentation of your tutorial. So we have a few questions for you. So the first one being, do we have the data for the rainfalls? It could be possible to see the amount of rainfalls in that area during that period, so we could see a correlation. You didn't study with the rainfall on the tutorial, if I'm not mistaken.
No. It is possible, but there is data for that. I'm not sure if it's on a Copernicus Marine Service
I think
platform
it would
or
be,
it's on Wikio mostly. I think it's mostly Wikio.
Wikio, yeah, Copernicus
because
atmosphere.
yeah, because it's atmosphere, so it has like error 5 and other products. But yeah, for this it's gonna be yeah, it's another platform. But it's true that there are data about rainfalls, about all the precipitations, also snow. Well, I don't think there's much snow in this area, but and yeah, you can also use this data and find some correlation between this data we used and the data you asked about. Yeah.
Exactly. So yeah, if someone wants to complete the tutorial with rainfall, they can add extra data to do that. Yeah, definitely. This question about the project. So which of the Copernicus Marine products contain wind speed and direction? I think you detailed the project you used.
Yes, it's a global wind reanalysis. I think I can really check very quick. I think there is, yeah, it's global ocean hourly reprocessed sea surface wind and stress. Well, first of all, there are several products. I'm more than sure there are several products that can contain these variables. It just depends on the region and on the time frame, because sometimes they're not available for a specific time. Just go to the web platform and you can put in the filters wind, and it will show you products that fall under these conditions. So yeah, but all the data that I use specifically for this exercise is all stated in a PDF file, and it's also, I think, if we provide QGIS file, we also provide the data used, so it's also there.
Yeah, all of the repository.
Yeah.
Okay, thanks. This one being a more general question, what are the challenges in analyzing the dual impact of hurricanes on ocean ecosystems, considering both their nutrient benefits and long-term dangers?
Direct challenges. Well, yeah, as I said, it's a complicated question, but well, as I said, yeah, it's mostly it depends on the duration, of course. If a hurricane passed very quick, it didn't bring much disruption to the ocean. The longer it happens above the ocean surface, the more it impacts, of course. And of course, it depends on its intensity. If it was, well, wind speeds and wave heights were not that impressive, let's say, of course, it's also it impacts the mixing process. So if it mixes less, of course, it's well, less influence on an ecosystem. But if it happens for longer period of time, if it happens more intensely, well, it does disrupt it for longer. But well, we kind of know that hurricanes usually don't stay that long. They usually pass like quite quick in like, well, I think a couple of weeks, maybe more. I mean, I'm not very like into hurricanes specifically, but they're usually quite violent, but also quite quick. So
Thanks for the explanation. Okay, so next question about, so what kind of output does QGIS coding produce? Layers, numerical data, or graphical information?
So basically, it produces all of these three types, let's say. Every time when you perform some new procedure in QGIS, you're most likely going to have a new layer. And these layers, well, you can save them or not save it. It really depends on you. But if you want to use them for later, of course, you have to save it. And well, layers can be saved in different formats. Can be TIFF, it can be NetCDF files also. It can be various types. So it also can be CSV files. So this is numerical data you can process after, I don't know, if Python or whatever. graphical information also, well, you can save images. You can even make GIFs, I think, and videos with different plugins, because QGIS has numerous plugins also. So yeah.
Thanks a lot. Okay, so next question. So this one is a more general question, but I can answer. What are policies for using this data for commercial purposes? So you can use the Copernicus Marine data to do, well, almost whatever you want with it. You just need to cite where the project came from, but as you know, it's free of charge to access and download, so you can use it and just think to mention where you find the data. That's the only thing to know. Next question. Any project or dataset could provide more information on the nutrients present in the ocean, possibly at various depths, at different stages?
Yes, there is a data set. It's a biogeochemical reanalysis forecast, hindcast. Well, there are a lot of them, and yes, we have data about different nutrients such as chlorophyll. We have nitrates. We have oxygen. Well, phosphates. Lot of different variables, and yes, it's also on various depths. Usually, well, it depends, I think, on availability, but it has several levels of depths too. Yes.
Thanks a lot. And same kind of question. So can the project use it for the simulation, which is related to ecosystems, distinguish clearly between affections on coral reefs and mangroves, for instance? I think you have to have external data to study that.
Yeah, I think first of all, well, you need to know specifically where the coral reefs or mangroves are, right? So for this, you would need some additional layers, additional information, and clearly distinguish clearly. Yeah, well, I cannot say that because, well, there's always lot of conditions that impact at the same time. So, but yeah, I mean, sometimes it's very clear that specific phenomena, specific event affects well, specific area, specific. Yeah.
Okay, thanks. This question, so it's something I didn't notice. Is there a technical issue with the wind data overlay? The hurricane appears clockwise, but in the northern hemisphere it should be anti-clockwise. Could you clarify? I didn't notice.
Is there any reason that the hurricane appears clockwise? But well, from what we saw in QGIS, let me just see. Is it clockwise or? Yeah, it was clockwise. In the anti-clockwise, I'm not sure really. No, I think it is exactly as it's supposed to be. I mean, if we see the satellite image, and also we see the this vector layer I showed with the direction and speed, it all goes well. Yeah, I'm probably mirrored right now, so but yeah, it goes clockwise.
Okay, thanks for the clarification. And so the last question, we will have time to do this one about the data you use for coral reef. So it's external data and you provide.
Yeah, it wasn't coral reef. It's the
yeah.
It was, what is it? Essential fish habitat, I think it's called. And yes, it's from a governmental site of what is it? National Oceanic and Atmospheric Administration of United States. And this is also open source data. You can access it, you can download it freely. And the links to it also given in materials. So you can have it if you have all our materials for this tutorial.
Okay, thanks a lot. So yeah, for the question about where to find the materials, I will provide you the link in the chat, don't worry. Well, thanks Daria for your presentation in the Q&A section. It was really nice. And yes, so now we can go to the RStudio tutorial. So thanks again, Daria, and welcome, Simon.
Yes, hello everyone. I will share my screen. Do you see my screen?
Yeah, it's okay.
Yes. So hello everyone and welcome to this practical session about cement data on eutrophication in coastal water in Adriatic Sea. My name is Simon Millet. I'm a certificate engineer at Novartis in France, and I will be your trainer during this session. We will use a Jupyter Notebook to see eutrophication in coastal water in Adriatic Sea in air. You will have a closer look at cements product, their structure, format, variable, and how to explore and plot them. So today, during this session, we will have a closer look of biochemistry and current variable in Mediterranean Sea. After exploring the dataset, we will make a basic plot. Then we will compare different variables, different date each other. Then we create an animation of annual evolution of phosphate. And finally, we visualize the current. So first, this training focused on eutrophication in Adriatic Sea near the northern region influenced by the Po River. It is a process driven by the excessive input of nutrients like nitrogen, phosphate, nitrate. And these nutrients are originate from agriculture runoff, urban wastewater entering the river and subsequently to the sea. So the river Po is the largest in Italy and significantly contribute to nutrients in the northern in Adriatic Sea. So this string we allow to see the evolution of different parameters, phosphate, nitrate, chlorophyll over the time, and the impact of the current which carry these nutrients over a large area along the west coast of Adriatic Sea. So first of all, we set up the air environment. So the Jupyter Notebook have a necessary available tools from Jupyter Notebook ecosystem. So here there is 8 libraries. There is the ggplot2 that is for creating graphic, dplar for manipulating data, air color border is for color palette in plot, and netcdf4 it is an interface for the netcdf file format. Grid extra it is for arranging multiplot on a page. Lubridate it is a library and user-friendly analysis for date time data. Magic it is for image processing. And ggquiver it is a package to provide a quiver plot for current, for example. So here we load all libraries. And if you are using another support and the library are not installed, you can run this line to load to install a whole package. So the data for this training, we will use a biogeochemistry reanalyze data. Here you have the spatial region in Mediterranean Sea. We only use the surface, here the variable, and the time period we use monthly means from January 2011 to December 2021. So it is possible to download the data in Copernicus Marine Data Store here. And when you click on Mediterranean Sea, you have all data. So for this training, we use this data and this data. but whole dataset are already downloading in this training. But if we want to try, it is possible. First of all, we set the path of a netdef file. So all the files are already downloaded. It is in this folder data and here. So we set the path, we load the netdef file and print the information about this file. There is 3 variables, ammonium, nitrate, phosphate. And for each variable, there is 4 dimensions: the time, the depth, latitude and longitude. And we see the depth is, the dimension is only 1 because we study here only the surface. And here it is the global attribute to put information about the data set. So then we load all variables. It is possible to see the dimension of a variable with dim, or the value of a variable. For example, is phosphate for 1 latitude, longitude, and time. It is possible to see the time, but here you see that the time is a number and not the date. So to convert in a date, we use this function as POSIX, and we put the origin. Here it is January 1970. The origin is done here. So now we have a date. So we will make a basic plot to see a map of phosphate. Donc, first of all, we determine the figure size. Then we create a data frame with longitude, latitude, and the phosphate for the first time. And we visualize the data frame. So here for each longitude and latitude, we have the phosphate. Here there is a whole NaN value because for the longitude and latitude show here, it is on the land and not on the sea. So there is no phosphate data. And here it is the function for plot the map. So we use ggplot. We add the phosphate data. Then we add the color scale. Then it is a general aesthetic option with the title, subtitle, the size of a color bar. And then we save in the folder figure. So we see the map here. So here it is a cartographic representation of phosphate in January 2011. We see a high concentration of phosphate in the northwest of the Adriatic Sea. That is corresponding to the river, the estuary of River Po. So this river import many nutrients. So here we see the phosphate, but we will see a different variable in this part now. So first of all, we load another file. We load each variable. And here we create a function. It is for simplify the code. It is the code inside this function. It is the same that we see before here to map. Then we define the index, so the time, and we plot in a variable each variable. So phosphate, nitrate, chlorophyll, and phytoplankton. And then we plot the four maps for the same date. And we see a great similarity on phosphate, nitrate, chlorophyll, and phytoplankton. The nitrate and phosphate, which are discharged by the river Po due to industrial wastewater, urban wastewater, agriculture. These nutrients develop the chlorophyll and phytoplankton, which can cause a bloom here. And we see that the correlation between the four parameters is very high. But until now, we see only one. So we will compare a different date in 2011, January, April, July, and October, to see the evolution over the years. So first of all, we define the date for phosphate. So the first date it is for January, here April, July, October. And then we plot the map. And we see that in winter there is more concentration of phosphate than in other months. It is due for two reasons. First, it is because in winter the rainfall is more important, and and bring a significant amount of nutrients, including phosphate, but nitrate over. And in summer, there is a stratification that prevents nutrients from deeper, lower from reaching the surface. So it is for this there is more nutrients in winter. So in the previous part, we only visualize the evolution of phosphates in 2011. So the question is there the same evolution each year? So now we will work with the whole time period. So January 2011 to December 2021. So first of all, we create a data frame with all the date. Then we do an average per month for all the years. So we group by the data frame, we group by months. So for each month, for each January month, we do an average of phosphate, and we do the same for February, March, April, etc. And then we plot we plot a map for each month. Here it is a function for mapping the data frame. It is approximately the same but before, but here we work with data frame, not a matrix. And here we create a whole map. I have already created the maps because it takes times. Then we list the whole PNG file. So the whole figure are here for each month. And then we do a GIF. Here we can see the GIF. So we can see the evolution of phosphate for each month from 2011 to 2021. And thanks to the GIF, you can see the monthly evolution of phosphate, and it it is in winter where the concentration of phosphat is the most important. It is the same conclusion than we see for the years 2011. So if you want, you can test other variable to see the monthly evolution. Here it is the part of to visualize the current. So in the previous part, we see that nutrients move from north to the south of Adriatic Sea along the coast. So we will verify that it is current that transport this nutrient. So first of all, we define the new file with a current. We create the norm with eastward and northward current. We create a data frame and then we plot a map with ggplot and geom-quiver. And here we see the current for January 2011, and we see that current move from north to the south near the coast, and we clearly see that for this map in January 2011 is carrying the nutrients towards south to in the west coast of Adriatic Sea. And so the Po River that is here has an impact in the entire east coast of Italy because of current that propagate the nutrients. So this training is now finished. Thank you for your attention, and we hope you enjoyed this training. If you have some question, do not hesitate.
Thanks a lot, Simon, for your nice presentations. We have a few questions for you, mainly about why the Earth script is a notebook. So,
yes,
yeah, go ahead.
I use a Jupyter Notebook for Earth script because it is easier to have a presentation because we have a text and code in the same page.
Okay, thanks. So the question is the Copernicus Marine Air package still active, and can I use it to download data subset?
I don't know really if it is possible to download data directly in air. I don't know. Sorry.
I think it would be just with the toolbox and the browser file and everything Anais shows earlier, but yeah,
Okay.
not without. So this one, can you run the research in RStudio? What packages are required to do so?
I think it is the same that we use. So in the presentation we use 8 libraries, and I think it is this package that is most useful for research in RStudio.
And yeah, for the previous question about the Copernicus Air library, you can use it to download data. Just add the information. And so, yeah, so for this question, if I want to download data subset using Air, I always have to switch to Python environment first. So I would say no, because of this information. So now you can directly use Air if you want. Okay, so I have lots of questions coming. So this one, can we use JupyterLab to work in this Air CMAPS data, or is it only for training? So you can have access to the Jupyter Hub for 2 weeks, approximately. So right now, when you connect to it, you can find the tutorials of this training, but it won't be available forever, and the access will be cut. So it opened 1 week before the event, it will be cut 1 week after the event. So it's mainly for training. Lots of questions. Is the R package enough to get the results you need, and will those results be presented graphically or just as a coding output, like table and numbers?
Yes, R package is enough to have the result that I show. And the second question, and will those results be I don't understand really the second question, but if I understand, the code inside the Jupyter notebook, it is useful to see to visualize graphically. So the coding input. I don't understand really the question.
Yeah, I'm not sure either. So I will put it on the side to think again about what the meaning is, but yeah, I will put it on the side. Next question. Does the current map shows current direction or velocity?
The both. We have the color that represent the velocity, and the quiver show velocity and the direction too.
Excellent. Next question. So the Adriatic Sea is shared by multiple countries. How can coordinated monitoring of nutrient inflows from different regions be effectively implemented? Good question.
In between, we look at only in the Po River in the northwest of Adriatic Sea, but there is also other river and more nutrients for other location that impact the Adriatic Sea.
Okay. So the next question, more general question for the user support. So some Mediterranean Sea products were not available for access through Air Copernicus Marine package a few months ago, as it's been updated and fixed. So normally the updates are made regularly, but not knowing the products concerned, I wouldn't be able to tell you, but I can put the question on the side and you can also provide extra details if you need. And the user support will answer this question on the post-event report. This question also, since not all algal blooms are harmful, can we distinguish between different species? So I guess you would need to use external data, if I'm not mistaken.
Yes. Some algal bloom are harmful because that disturbance for example, oxygen, impact food, etc. But there's different bloom, alga bloom, and with other data set, maybe we can different species.
So, can I use this freshwater in the largest lagoon in Iberian Peninsula? So I guess if we change the coordinate and the product you used, your tutorial can be used anywhere.
Yes, of course.
Yeah, okay. Thanks. Okay, so I'm just looking at the user question. Okay, so concerning the tutorials, this was the last question. So for the other question, the more general question and the question concerning more of the specification of the user support, I will come back to you with the post-event report. So Thanks again, Simon, for your presentation in the Q&A section. So we are reaching the end of today's session. So I hope everyone enjoyed it, and thanks again to all of our speakers. I just want to remind you that the tutorials and the full video demonstration are available on the webpage event. And on the Copernicus Marine website, you can also find the full catalog of past tutorials. So don't hesitate to have a look of past tutorials or these tutorials. And also, I just want to ask you to take a few minutes of your time to fill in the survey we made for this workshop. So it would be wonderful if we could know what you think about this format of webinar and what you thought of today's session. And it can be really useful for us to improve. Concerning the replays, everything will be made available today during the afternoon. So the first day is already available with the PDF presentation. And yeah, you will also receive a certificate of attendance after the event. So no worries about that. And yeah, for the post-event report, it will be made available a little bit later. So yeah, thanks again, everyone, for your participation. I hope to see you for the next training. It will be at the beginning of March on the 3 and 5, and it will be marine data for Africa training. And yeah, see you everyone, and have a nice day. Goodbye.